and gas subsea pipelines are the most economical and efficient means of transporting large-scale crude oil and natural gas. In spite of this, operations of subsea pipelines have been beset by a perennial flow-induced corrosion problem that significantly reduces lifespan of subsea pipelines. High corrosive agents, such as CO2, H2S and chlorine compounds moved along during the transportation of crude oil and natural gas accelerate the corrosion process inside subsea pipelines. In the unfortunate event of subsea pipelines failures, leaks cost operators millions of dollars to repair and in extended operations downtime.
We have more than 2,000 kilometers pipeline with a total of 153 pipelines that we have to manage in SK Oil. So it shows a very important component to support our production. So our production, like this year, we have to produce nearly 100,000 barrels per day.
SKO, specifically the Baram Delta fields, was where the oil and gas operation started in Malaysia. And some of the facilities have been operating for 40 years now. One of the challenges we face today is finding cheap and effective solutions to extend the life of our existing pipeline. Based on extensive research by Petronas, the IFL technology was developed.
In-field liner, IFL, offers the most ideal solution the industry has to offer to date. Technologically and architecturally advanced, ingenious IFL innovation provides a two-pronged solution. While enhancing corrosion resistance, IFL increases lifespan of oil and gas subsea pipelines up to more than 30 years. In addition, IFL reduces the complexity of subsea pipelines maintenance by negating the impact of changes in fluid composition within a pipeline. Oil and gas subsea pipelines are prone to internal corrosion. Over a period of time, pipelines that run from platform to platform and offshore facilities are oftentimes severely exposed. Internal corrosion may cause a pipeline to prematurely reach the end of its intended lifespan. In effect, a corroded pipeline is usually replaced and relayed as a standard industry practice or as a consequence of a more cost-conscious consideration, left abandoned.
In handling and introducing and executing the work that is involved in the IFL technology. Indeed, right now, after replacing 4 pipelines from carbon steel to IFL, we have indeed realized real saving. Yeah? If you look at in terms of the capex expenditure, we have realized to a tune of something about 200 million.
In an effort to address this natural deterioration process, in 2011, Petronas and APS took on the challenge to come up with an alternative solution to rehabilitate corroded pipelines. Based on an already proven framework, a 3-year multi-million-dollar R&D project was commissioned.
We will continue this technology. It's part of our resolution to address current economic situation, in particular to oil and gas. And we believe this IFL technology will help us to reduce capex as well as low OPEX.
Pertinently, with much forethought, the main objective of this R&D, in particular, was to help offshore operators offset the astronomical costs of relaying new pipelines. To achieve this, the R&D was focused on the development of robust and flexible composite materials to be inserted into an already corroding pipeline. A spin-off of Petronas Dispersed Innovation, In-Field Liner, is forecast to save oil and gas operators all over the world millions of dollars from the costly implication of replacing corroding subsea pipelines.
This technology was the only credible option that was available for us to improve the integrity of some of our high-risk pipelines. So working with our partner APS Malaysia, we embarked aggressively to develop and install the 10-inch.
A first-time feat, IFL is engineered to be readily adopted into the most common subsea pipelines configuration. IFL's benefits are a boon to offshore operators. IFL extends lifetime of existing pipelines for a minimum of 30 years. Offers an economical alternative solution to the more expensive laying of new carbon steel pipelines. Cuts precious time designing, planning and installing a new lay. Provides a higher resistance to the most aggressive hydrocarbon exposure. Kevlar core provides remarkable high tensile strength, enabling long length insertions.
When we do this IFL pipeline replacement in a single campaign, we are saving to a tune of about 50 million, just looking at optimizing of how we approach in doing the work activities offshore. Indeed, the pipeline team and also the service providers together have been challenged in terms of the weather, in terms of the time they have to execute all this problem. But with all the collaboration and with all the cooperation by both parties, I think they successfully delivered the objective that we had. This IFL, indeed will be the game changer for us in terms of managing our very high risk or high risk pipelines.
IFL's technology has undergone a tremendous growth spurt. Following successful prototyping and installations, post-installation results clearly substantiate in field liners' industry benefits. Previously, there had been no feasible method to install an internal structural corrosion barrier into high-pressure subsea pipelines. Furthermore, installation of corrosion-resistant liner was just not possible over a distance of more than 1 kilometer due to previous technical constraints. Consequently, replacement ineffectively equates to operations cost increase and an extended downtime. In contrast to this, with the advent of IFL, pipelines rehabilitation is made cost-effective and operationally viable for the first time with flexible Kevlar reinforced PVDF liner technology. After rigorous stages of testing and development, IFL's design efficiency, durability and robust architecture proved to be the best cost-effective solution the industry has to offer to date. Offsetting the high costs of a new lay, in addition IFL strong, durable and offers a snug fit. Significantly, IFL structure is sturdy and with its clever mobilization technique, IFL can withstand long-distance towing without causing damage to the liner. The development of IFL has simultaneously spurred a salient industry breakthrough. Lifespan of existing pipelines will be extended for a minimum of another 30 years, hence making IFL the best solution for rehabilitating dilapidating subsea pipelines. IFL's technology encompasses a thorough work procedure. This procedure involves onshore preparation work, offshore preparation, pipeline de-oiling, pipeline cleaning, dewatering and riser modification, IFL insertion and hydro testing. On the other hand, onshore preparation was carried out. The folding and bending of IFL and attachment of the pulling head. Equipment inspection and test run. Fabrication work. Spools places. Framework. Riser section with vent. Offshore liner drum and riser telescopic clamps. Concurrently, offshore preparation was carried out. Scaffolding and fitting prepared the final setup for the task mobilization of IFL's installation. Upon assembling all the necessary equipment at the offshore facility, the preliminary tasks of pipeline cleaning and riser modification were executed. This included pipeline de-oiling, pipeline cleaning, pipeline gauging, riser clamp installation, topside piping removal, pipeline dewatering, sending messenger line. Providing a full bore tight fit and longevity within the host pipe even in the most aggressive hydrocarbon exposure conditions, IFL has a high standalone burst pressure that allows it to function as a dual containment rehabilitation mechanism within a dilapidated hydrocarbon pipeline. Pipeline cleaning is a prerequisite requirement before IFL can be installed. Using the pigging method, a variety of pipeline pigs and swabs were used during the cycles of cleaning and flushing. Full-bore plastic discs ensured that pipelines were cleaned of remaining fluid and loose debris. Subsequently, treated seawater was used to further enhance the cleaning process. Finally, The pipeline was dewatered using tighter fitting plastic pigs. Treated seawater was used for the process of removing any residual hydrocarbon after the initial pigging and swabbing process had been completed. Next, a gauge or a testing piece was pulled through the pipeline. The gauging process was thoroughly executed to ensure no harmful snags that could damage the liner during insertion were left. Following this, a lightweight cable was sent through from one platform to the other. With the help of a messenger pig, a heavyweight cable was pulled back to the first platform. Riser cold cutting and flange modifications were necessary preparation steps at both ends of the pipeline. These two steps enabled IFL's termination fittings to be installed at the ends of each riser situated on both platforms prior to insertion. Without fuss or fanfare, IFL was towed into position inside the old pipeline at a consistent speed of 10 meters per minute. Installation was initiated from the deck of a vessel. Pulled by a towing cable using high-powered winches, mobilization began with the folded liner pulled through the host pipeline from host platform to receiving platform. Pulling force was carefully monitored to ensure that no undue stresses were applied to the liner during the process. Upon completion, the folded liner was inflated to break the restraining tape. Now, the liner is reformed to its full bore circular size that fits into the internal diameter of the host pipe. Fitting of a termination flange was carried out. This locked the liner firmly to the pipeline's flange to ensure a snug fit of the flange riser. Hydro testing and recommissioning of the pipeline then will be done. Commissioning was resumed upon the completion of the following procedures. Installation of the end connectors at both ends. Inflation of IFL. Flooding IFL pipeline treated seawater. Hydro testing. Dewatering.
So far, for SKO oil, our pipeline team has successfully delivered the objective of the IFL execution. I would like again just to express my sincere appreciation and thank you to the team for providing the avenue for SKO oil to demonstrate the game changer.
Okay, next step for the improvement for this IFL that we are looking at, there will be a tremendous effort in reducing the capex, especially during the installation of this IFL as compared to the normal carbon steel pipeline. The cost comparison, we can say that you can reduce 3 to 4 times of the cost for this technology as compared to the normal conventional technology of installing the pipeline.
So for those who have longer pipelines, Petronas is working to make sure that we can improve the length and the capability of the current IFL, so we can provide what you call a low-cost pipeline integrity solution. And we're also exploring on making the liner intelligent, so the liner is able to self-monitor itself to enable us know when it is degrading. So maybe using some things like fiber optics.
I would like just to highlight the achievement by the project team. First and foremost, I would again like to congratulate and recognize the effort being put by our pipeline team in SKO oil. They indeed demonstrated ownership, they indeed demonstrated focused execution. All in all, they demonstrated result matters.